The body prepares the endometrium like a sperm was coming to fertilize the egg, and like this whole thing was going to result in a pregnancy no matter what. So we're going to deal with that up through day 28. The body's going to pretend to prepare for pregnancy even though there may be no pregnancy that's going to happen here. So see how progesterone levels tend to rise after ovulation. This follicle here actually degenerates. And once you get past ovulation, that follicle starts to degenerate and die, and the death of that follicle is called, it's going to be ultimately the cause for menstruation here starting after day 28, which puts us back here at day 0, day 1. So, this corpus luteum is the name for the degenerating follicle. That's going to be a major player for us as we go from day 14 onward.
Yeah. So that phase only takes place if there's no sperm.
Well, this is going to happen regardless.
Okay.
So we're going to pretend right now that there's no sperm. So this follicle that ruptured and sent out the secondary oocyte is actually going to continue to be a player in this whole cycle. That follicle is going to form what we call a yellow body, or corpus luteum. It produces progesterone to help maintain the thickness of the endometrium. Of course, the body prepares for pregnancy whether one is going to occur or not. So you'll notice that progesterone levels rise until we reach around day 28. By day 28, that corpus luteum is essentially gone, it's degenerated, and the death of the corpus luteum means progesterone levels do what? Drop.
To get pregnant, they keep rising, rising, rising.
That's right. You're right. So for a successful pregnancy, that progesterone level has to be maintained. And eventually the placenta is going to produce progesterone to maintain the pregnancy. But hey, if that corpus luteum is gone, then the progesterone levels drop, and the female then starts back over with day 1 with the menstrual cycle, menses or the period.
That corpus luteum only drops if you're not pregnant?
Right. So this scenario here of the corpus luteum dying is for not pregnant. So if you've ever wondered why females have water retention around the time before their periods, you can thank things like progesterone and estrogen. They are steroid hormones, and like any kind of steroid, they bloat you and cause water retention. So there you go. Those progesterone levels actually are the cause for those hormonal changes before a female's menstruation time. Now, let's take from this picture, and I'm going to actually take you into embryology, which is page 155 in your course pack, and we're going to work through what happens if a pregnancy does occur. Okay, so obviously the pregnancy can occur around day 14. And the progesterone levels will increase and stay increased because this secondary oocyte was fertilized in the fallopian tube, but it's not supposed to implant there. So where's it heading? Yes, good. Endometrium of the uterus. So let's say that we're approximately day 14. We have a secondary oocyte that has stalled in the meiosis tube. Well, that sperm does not need its tail, so upon fertilization, bye-bye tail, all we need from that sperm is the head for the DNA to housed. Alright, so what we're going to do now is, within moments after fertilization, all other sperm are prevented from fertilizing the egg. A chemical change prevents those heads of those sperm from entering the cell. So fertilization now produces the very first cell of the next organism. This is called a zygote. It is a single cell that is now diploid again.
So you kind of started like in the middle of that thing?
I'm actually, for the secondary oocyte is ovulated there at day 14. I'm just taking you on the route of if it's fertilized.
So when it says 23, it's 2 ends.
Yeah, 23 is 1 end, 2 is 46.
Okay.
Okay, I was trying to figure out what it was.
Okay, I see what you're talking about. Yes, there's that about halfway down the page. Now I'm going to take you to the bottom of the page where it says 16 cells. The process of rapid cell division is carried out by mitosis, and this process is called cleavage. So cleavage rapidly produces 2 cells, 4 cells, 8 cells, and then a 16-cell organism. This is a solid ball of cells that is now floating along through the fallopian tube. Where is it heading? Uterus. Yes, so we're heading now with this 16-cell morula down toward the uterus. Morula means raspberry, and it really is a solid ball of cells that looks a lot like a raspberry. At this stage, if they do in vitro fertilization, they can sample out a cell or two. They can look at it under the microscope and see if there's any genetic abnormalities. Because at this point, none of these cells have decided what they're going to grow up and be. So it's not like you're removing an arm or a leg. If you sample out a cell, all you're doing is taking an undifferentiated cell at this point. And that's what they do with in vitro is, if they're looking for genetic problems, they'll pull something out at this stage.
So are they all identical at that point?
They're all identical, right.
Okay.
Let me flip you over to page 156. It's not long here, just a few days, and this zygote has now turned into a blastocyst. This is actually a hollow ball. It has a layer of cells around the outside, and it has a collection of cells inside known as the inner cell mass. Now we're starting to differentiate these cells into what's going to ultimately form the embryo, the fetus, and the baby. So at this point, we now have differentiation of cells. Okay, this outer layer of cells here is called the trophoblast. That particular portion is going to implant into mom's uterus lining. The problem with implanting into the fallopian tube is there's a lack of a good blood supply and there's not the stretchiness of the muscle. So implanting in the uterus is ideal because there is a good blood supply and it's stretchy with that myometrium muscle. That inner cell mass ultimately forms the baby. That inner cell mass differentiates into 3 germ layers. So we go now through a process called gastrulation, where we form an ectoderm, which is skin and nervous system, mesoderm, which is muscles and connective tissues, and endoderm, which is the inside lining, like your digestive tract and the linings inside your body. So that inner cell mass ultimately differentiates and develops into the baby. How far are we after the point of zygote formation? How many days? 7 days, yeah. So we're looking at a well, actually, implantation is approximately 7 days after fertilization, so if you're keeping track of our cycle over there on the board, if this egg was fertilized at day 14, we are now at day 21. You see where I'm coming from? Okay, so if you were fertilized at day 14, we're now at day 21 on the cycle. Some women may spot during implantation or have cramps during implantation and think, oh, I'm just getting my period early, having no idea that this process is actually already set into motion. So 7 days after fertilization, we now have a blastocyst. The blastocyst includes the inner cell mass, which becomes the baby, and the outer trophoblast, which implants or digs into the wall.